To test correlation, let's create a new workflow and input our data from the new product control data file. Since our data is in a CSV file, let's use the AutoField tool to take care of field types and automatically assign them. Now we can perform association analysis to investigate if the number of products does in fact drive sales. To perform the analysis, we'll drag the association analysis tool onto the canvas and configure it to check for correlation between product count and sales. If the fields window is blank, run the workflow to populate the data. We can now select category sales and product count. After adding a browse tool to the eye output, we can run the workflow and take a look at the results. Expanding the output of the browse tool, we can see that category sales is fairly positively correlated with product count with a correlation coefficient of 0.43. This is evidence that product count should be controlled in the experiment since sales is related to the number of products sold at the stores. Next, let's test to see if there is a relationship to sales due to the size of the store. Since the size of the store is not a numeric variable, but rather a categorical variable, we can turn to a plot of means analysis to identify if there is a pattern in sales as it relates to the size of the store. In Alteryx, we can use a plot of means tool that simply plots the means of each variable in the data set you select. It's a great way to visualize how the mean of a variable differs across categories. To read more about the plot of means tool, see the note below. We'll select category sales for the response field, and the categorical field that we're grouping by is the size of the store. Prior to running the workflow, let's add a browse tool to the output. Expanding the browse tool provides us with a plot of means of category sales by store size. When viewing a plot of means chart, ensure that your categorical variables are ordered in a logical order. In this case, large, medium, and small are in logical order, so we're good there. If there was a correlation between the size and sales, we would expect to see a more linear relationship. In this chart, there does not appear to be a pattern that correlates the size of the store with sales, so we don't need to control for store size in our experiment. Lastly, we want to look at how many stores we have in specific geographies so that we can determine if we can use that as a control variable. Let's drag a summarize tool onto the canvas and group by city, state, and zip code. Then we want to perform a distinct count on the store ID field to count the stores in each area. Let's run the workflow to obtain the results. The data shows that most city, state, zip code combinations only have one store. There are too few stores in each group to have options to control on. Let's try grouping by state and city only. We can just highlight the zip code field and click on the minus button. Now we'll run the workflow and look at the results. Again, too few stores in each state and city. We are looking for a larger set of units per location. Since 15 is the minimum number of observations for a student's t-test to be applicable, that's a great target. If we group only by state, we see that we get a much larger number of stores per state, in most cases more than 15. Therefore, our assumption is that stores in the same state perform more alike than stores in different states. For example, a store in Alaska is much more likely to be similar to another store in Alaska than when compared to a store in New York. Therefore, since we have enough stores per state, we can control for state. We've now determined that we're going to control for product count and state in our experiment as both have ample data and are correlated to category sales, our target variable.